Having a household power backup system is an essential part of keeping your home not only comfortable but safe when the grid goes down. In this video, we'll be showing you how to install the Anker SOLIX F3800 as a clean and sustainable alternative to a gas generator using a transfer switch and inlet box to connect it to your home's existing main breaker panel. The SOLIX F3800 is a very advanced home backup power solution, but it installs just as easily as a conventional gas generator. And because it doesn't burn fuel, that means we can locate it inside living spaces in your home, which for us means that installing it next to our breaker panel is going to be even easier. Along those lines, we will be using a transfer switch, just like you would with a conventional gas generator, as we connect the SOLIX F3800 to our home's breaker panel. An important thing to note though, unlike other conventional small gas-powered generators, the SOLIX F3800 is capable of producing 240 volt AC power, which means we can power those large high-draw devices much easier than with a gas-powered generator. Because the SOLIX F3800 is capable of putting out 240 volts of AC power, it's important to pick a transfer switch that can accept that type of incoming power. For us, we're using the ProTran transfer switch from Reliance Controls that has two sides, each of which will receive one of the 220 volt AC legs coming in from the SOLIX F3800. At the bottom, we have the two tandem positions that will run our two 240 volt AC backup power circuits. And above that, we have 620 volt AC circuits that will power those loads. It's important when you're selecting this to pick one that has the appropriate number of spaces for the circuits that you want to power, in addition to making sure that the ampacity and breaker ratings on those circuits will match the loads that you want to run on those circuits in your house. This particular model will connect to our main breaker panel using the whip provided on it below. Each circuit has the ability to select whether or not it's powered by the generator, in our case, our SOLIX F3800, or the grid when the power is running. It's really important as you are wiring this and thinking about your loads to make sure that you connect it in a way that balances the load across the two legs of incoming power from the SOLIX F3800. When you're selecting the transfer switch for your F3800 installation, it's important to remember that the output of the F3800 is 6,000 watts, but it appears on two separate legs, each with 3,000 watts available to them. When you're distributing the loads across the two halves of your 240 volt AC transfer switch, you want to keep those loads balanced so that you're able to realize the maximum power potential available to you on each of the 3,000 watt output legs of the F3800. There are a lot of options out there when you're selecting your transfer switch, so let me show you why we chose the model we're going with today. The first step is taking a look inside your main breaker panel. In our case, we know the circuits that we want to run will be the water pump, the AC, and then the circuits for the bedrooms, the kitchen, and the garage. That means we need a transfer switch that has at least two 240 volt AC circuits that'll handle the water pump and our AC system. And we want it to have another 620 volt AC circuits. That'll take care of the bedrooms, the kitchen, and the garage. That's why we've selected the model here. As you can see, we have the 620 volt circuits on the top and the two 240 volt circuits below. Let's talk about some of the additional tools and materials you're gonna need if you wanna do this job yourself. The first thing you want to make sure you have is an appropriately sized cable with the correct ends for connecting the SOLIX F3800 into the inlet on your transfer switch. In our case, it came with the transfer switch. You'll want to double check and make sure that you have one, and if you don't, pick one up. Additionally, if you want to run any type of extra conduit, you want to make sure that you have any couplers or things that might be required, as well as the appropriate anchors for attaching the transfer switch to the wall. Once you have all of the correct materials, you're going to need an assortment of tools to get this job done, but it's nothing out of the ordinary. A conventional drill and driver will be very handy, as well as a hole saw that's the appropriate size for drilling through any studs or into the breaker box itself to pass our conduit into. We've got a voltage tester to make sure that we're working on safe wires. Additionally, we have wire strippers and cutters, an assortment of hand screwdrivers, measuring and marking tools, a drywall saw, and a hammer. For this particular installation, we will need to run wires through the wall, which means cutting a hole in drywall, and nobody wants to turn this into a drywall project. So we have picked up a 14-inch snap-in cover plate And what this does is it gives us the ability to open up the wall cavity, pull our wires from the transfer switch and get them into the breaker panel. And when we're done, this snaps right into place over our rough cut opening and gives us a nice finished panel that's removable even if we need to access it later. Now that we have all of our tools and materials, the next step is determining the exact location where our transfer switch is going to go and how we're going to route the wires from the main breaker panel to the transfer switch. The first step in that is pulling the cover off of your breaker panel. Working with the homeowner, we've decided that the best location for our transfer switch is going to be here to the left side of our main breaker panel. Now you can see our main breaker panel is recessed and lives in the wall, but our transfer switch is surface mount and lives outside of it. The way that we will be getting all of the wires required to connect to the breaker panel into the breaker panel is by cutting a small hole in this wall here, running our wires down across the stud and then up into the bottom of the breaker panel. We chose that path because the breaker panel is actually nestled in between two studs on either side. So rather than drilling through the studs and the metal walls of the breaker panel, we'll come down, drill through the stud on its own, and then have a clear approach up into the bottom of the breaker panel. We'll then be covering up the access hole that we made to do that using this cover plate that I talked about earlier. It'll snap into place here, hide any evidence of what we had to do to get the wires into the breaker box, and give us a clean looking install. Now that we have our installation planned out, we're ready to begin work on installing our transfer switch. The first step of that is killing power to the main breaker panel, and we'll do that in our location by turning this breaker at the top to the off position. Your main breaker may be located outside or in a different location, and you'll want to make sure that you find that and switch it to the off position before you begin work. While that will kill power to all of the circuits below it, it's important to keep in mind that the power feeding that breaker will still be live. So for us, we'll want to be very careful and make sure that we keep our hands and tools and other objects away from the top side of that breaker because it will remain live while we work on it. If any part of this makes you feel unsafe or unsure about your ability to do the job, it's never too late to hire a licensed electrician in your area to make sure the job is done safe and in compliance with local codes. In fact, that's what we've done in our case. We'll be handing that job off to him, but let's go ahead and kill the power. If you've got backup lighting in place, now's a great time to go ahead and plug that into your SOLIX F3800 and start enjoying its backup power benefits now, like we're doing here. All right, so Clint has been busy doing all the things that we talked about earlier, and I'm just gonna show you real quick visually what's been accomplished so far. The most obvious thing is we have our transfer switch installed at the location that we predetermined. And what we've done is we've routed the wires, this big bundle of wires, out the back of the transfer switch, through the wall, and through an opening here in the stud, and then up through another opening that we made in the bottom of the breaker panel to feed all of these wires into the breaker panel itself. You can see here we had to cut an access opening so that we could run those wires, and it will be closed up by snapping this panel into place when we're all finished. Gives it a nice clean look. The next step that we have for us is to now go in and hook all of these up to the circuits that we want to transfer power into our transfer switch. To do that, we will essentially disconnect each circuit at the wire where it comes into the breaker and splice in the transfer switch. The red wire will connect to the breaker, the black wire will connect to the load, and that will make it so that we now can control the source of power for that circuit based on the position of the switch on the transfer switch here. We'll get started with that. We'll let Clint take care of the rest of the real electrician's work, and then we can start testing it. Now that we've got all of our conductors ran into our main breaker panel, it's time to start connecting the individual circuits to their corresponding positions on our transfer switch. Since we know we want to connect our well pump, we'll go ahead and start there. The well pump is a 240 volt circuit. That means it has a tandem breaker, or two breakers right here that are connected. So we want to make sure that we're connecting that to a correlating 2-pole switch on our transfer switch. In our case, we're going to be putting the well pump on the D and I switches on the transfer switch. So that means we want to find the D and I wires that go to that. There should be a black D and I and a red D and I. And that is what we have right here. And if you look closely, you can see that these wires have those labels on them. For this particular model of transfer switch, the red wires are the ones that will replace the circuit wires on the breaker, and then the black wires will then connect to the circuit wires that were once connected to the breaker itself. We're essentially splicing the transfer switch in between the circuit breakers and the outgoing wires that go out and power each individual circuit or appliance. We'll go ahead and get those connected, and the process is the same if you're doing a single 120 volt circuit. There's just going to be only one breaker to connect to instead of two. We'll repeat that for all of the circuits on our transfer switch that we want to move over, and at that point we'll be ready to test this out. All right, so Clint has finished making all of the electrical connections within our main breaker panel. I just want to go over those real briefly with you to reiterate how we did it and show you what it looks like when it's done. The first connections we'll talk about are the ground and neutral wire connections coming out of our transfer switch. Very simple, there's only one of each. You'll connect your ground to your ground bar and your neutral to your neutral bar in the breaker panel. Then we went circuit by circuit, swapping out the wires that feed the circuits for the red wires that connect to the transfer switch, and then connecting the wires going out to the circuits to the black wires coming in from the transfer switch. I'll show you what that looks like here on our well pump circuit. You can see we've got the red wires that go out to our transfer switch. Those are now what are fed directly by the breaker. And then the white and black wires that once were the lines that ran out to the well pump, they're connected using these Wago connectors, or you could use wire nuts, to the black lines returning from our transfer switch. So we're essentially just splicing the transfer switch in between the circuit breakers and the wires that go out and feed the circuits for those outlets or appliances. Now that everything's wired up, we're ready to reinstall the cover on our circuit breaker panel and start testing out the loads. Now that we've got our breaker panel cover reinstalled, we can go ahead and flip the main breaker on and reset all of the breakers on this panel to their normal operating position. Once those are reset, we'll head over to the transfer switch and turn them all back on as well and set them to line to receive power from the grid. Great. Now that we've completed the install of the transfer switch, I'm going to show you the process for taking loads that are going through the transfer switch and connecting them to the SOLIX F3800. The first step in the event of a power outage is to grab your cord and connect it to the SOLIX. We'll plug it in here to the 240 volt receptacle on this side, and we can go ahead and power that on. We'll come over to the inlet. We will connect it to this side. And once power is being supplied by the SOLIX, we can now start transferring our loads from line to gen, which will connect them to the SOLIX F3800. We're now running everything on the transfer switch off the F3800, and we can tell that everything's working and being powered by the F3800 because we can see right here on the output, we've got 366 watts going out to our transfer switch, and that's just powering whatever happens to be on those circuits right now. The transfer switch is installed, the F3800 is wired in, and now we've equipped this house in less than an afternoon with the ultimate backup power solution. The best part of it all is that we'll never have to fill it with gas, change the oil, or breathe in those exhaust fumes again. If you like this video, make sure you hit the subscribe button so that we can keep you up to date with all the latest tips, tricks, and products to keep you living in power.